Hey, good morning, line students. Welcome to the last week of school, area puzzle number 2. This one's called Pythagorean planting. All right, so Pythagoras planted a bean bush so that one side was facing the sun and the other side was facing the shade. The side facing the sun produces red beans, and the side facing the shade produces blue beans. All right, so use the clues in the gray squares, all those shapes that are gray are squares, and the white right triangles, those are all right triangles, to calculate the difference in area between the red beans and the blue beans. Right? If your measurements are not whole numbers, use 2 decimal places. Okay? So I'm going to start off a little bit. I'm probably not going to solve this whole puzzle, just get you guys going. So first thing is kind of look at all this information that you have, maybe start to figure some stuff out. So from yesterday, I know that if I know this area right here, if this is a square, and this is, I know this area is 1156 square centimeters, then I can find this length of the side by using the square root, right? So a lot of the ones yesterday were sort of like in your head. You would be like, oh, it's 16, so it's 4. Nobody knows the square root of 1156 in their head, so 34. So that means this side right here is 34. Matter of fact, all these sides are 34 because it's a square. All right, so I know that thing. Remember, what I'm looking to do is I'm trying to find this area, this area, this area, this area, this area, and this area. I'm trying to find the areas of all of these beans. So I know this side's 34. All right, so the second triangle, similarly, I can sort of look at this triangle, square, excuse me, and this is 256. All right, so if that's 256, I can do the same math, square root it, and that'll give me the length of the side. That's 16. That means this is 16. So I know some more sides. Right away, I know I can see, I think I could figure out this box, that red box, because inside of here, there's a right triangle. Boom. Remember, all these white triangles in this picture are right triangles. So that's a right triangle. There's my right angle, right? We should be able to see that from inspection, just from looking. Shouldn't have to guess where the right angle is. So there's my right triangle. So that's like an a squared, b squared, c squared problem. So it looks like 16 is the small side, so 16 squared plus this side I don't know. We'll call this one b, plus b squared equals the long side squared. That's the hypotenuse squared, 34 squared. Now it's kind of weird because I already square rooted these, so I already know 16 times 16 is 256. Plus b squared equals 34 squared, which I already unsquared 34 before I square rooted it, so now I know if I actually square it, it goes back to 1156. Right here, side note, this can tell you something about the Pythagorean theorem, which is when you have it set up like squares like this, the 2 little squares add up to the big square. Who knew? So that means b squared, the area, which is the area of that middle square, is 1156 take away 256, so that's 1156 take away 256, and that makes 900. So now that means the side is square root of 900, and that is 30. Should have known that. All right, b equals 30. So then this, that was a b. So that little b is gone. And really what I have is 30. All right, so that means this side is 30. Right? It's a square. So I'm building up, right now as I'm working through this, I'm building up more and more information. Let's look at some kind of tricky ones. All right, here's a sort of a slight tricky one. We got that right there. Remember, all white triangles are right triangles. So this is, I got that to solve. So this is a situation where the two little triangles are equal to each other. So see how it says x centimeters and x centimeters? The math problem says x, and then somewhere else it says x. It should imply that those are the same value, right? You can't have x over here equals 5 and x over here equals 9. Right? In a geometry problem, when something's labeled x, everything that's labeled x is the same. So I have x squared plus x squared. Those are the two small sides. And the length of the hypotenuse is this long side right here, so 16 squared. So that's 2x squared. I don't know if you remember that. We did a couple problems like that. 2x squared equals 16 squared, which I already know is 256 because I square rooted it already. All right, solving this little guy, divide by 2. Just PEMDAS, right? Undoing inverse operations. Boom. So that leaves us with x squared equals half of 256, which is 128. So that means x is square root of 128. Be sure that's not a whole number. So now, so we got second 128, and that is 11.31. Because remember, we're doing 2 decimal places. Just truncate at 2 decimal places, right? You don't need a round. Just cut it off at 2. So that means that both of these are 11.38. And 11.38 right here. Which means this is 11.38. Right? 11.38. All right, so I'm already to this bean. So what do I know about this bean? I know this thing is a 1, 2, 4, 5, 6. So hexagon's a regular hexagon with 6 sides. So it's going to be 6 times the apothem, which is 12, times the side length, which is 11.38. You know, I wrote 3.8, and these are, must be losing my mind. These are all 3.1. Right, because we did this calculation right here. That was 11.31, and I proceeded to write 11.38. I can't believe you guys did not warn me or correct my mistake. You guys are slipping. So this is 11.31. So 6 times 12 times 11.31 over 2 is going to get me the area of that beam. So let's go to, oh, I can't zoom in here. So let's look at this situation. got 11.31 right there. We got the short side, and we got the middle side. So we only got one side of this triangle. So question, we know the area of this bean. We don't know the area of that bean. So I'm going to leave this for you guys to figure out. What do we do in that scenario? Okay, so you guys, I'm going to leave you guys to figure some stuff out. I just kind of got it started off. That's pretty much it. Things to take away from this. Right, so some weirdness or some, when you have the area, you can square root the area to get the side. We know that from yesterday. All of these white triangles are right triangles. When they're right triangles, you can use a Pythagorean theorem. A squared, b squared, and c squared. We remember the area formula for regular polygons. That was the number of sides times the apothem times the side length divided by 2. Okay, and then the sort of weird thing, this is about the Pythagorean theorem, but it's not necessarily obvious, which is if you have a situation where you have squares set up around a triangle like this, you have the large square, and that equals the sum of the medium and the small. So 900 plus 256 makes 1156. Okay, we never really went over that. That's kind of like a, I don't know what that is. It's an implication of the Pythagorean theorem. All right, that's it. You got to do the rest on your own, and then there's a second one where you got to start from the beginning. Same question. What's the difference in size between the red beans and the blue beans? So what that means is you calculate the area of all the red beans, calculate the area of all the blue beans, you add them up, right? You add up the red, you add up the blue, then you subtract. You find the difference between the two. How much bigger is one than the other? All right? Good luck. Couple more days left. You're doing great.